Exponent one, and welcome to this video introducing exponents and square roots. It's gonna be awesome.
It's gonna be lame.
Skeptics.
I'm not a skeptic. I'm just a disembodied voice.
And I'm gonna edit you out of this video. Let's get started. So, this video is designed to be an introduction to exponents and square roots. Exponents where we'll have something like x squared or like 5 squared, and square roots where we have the square root of a value like the square root of 36. So when we talk about exponents, powers, and square roots, what are we talking about? First off, when we discuss power, we're talking about something that is multiplied repeatedly. So something like 5 squared would be 5 times 5, or having two 5s multiplied together, which would make 25. And you can always rewrite something that's multiplied repeatedly as an exponent. So the 5 times has an exponent of 5. This is how you write powers. Then there's square roots. Square roots are almost the opposite. Notice here that if you square root 25, you get 5 back. And that's because when you're dealing with perfect squares, you're talking about what times itself makes the number I have. So what times itself makes 81, for example? Well, 9 times itself would make 81. Next, a perfect square. There are only so many square roots that actually come out to something of a whole number. See, when you have a square, you're talking about something that has a length and a width, and if it's square, then those length and width are the same thing. So 3 times 3 is 9, 4 times 4 is 16, 4, 9, 16, 25, and 36. These are all perfect squares, and it keeps going. 49, 64, it continues on and on and on. However, there are only so many of these perfect squares, and the numbers in between are not perfect squares. Why would that matter? Well, because the numbers that are perfect squares, or the numbers that square root nicely, are rational numbers. They're numbers that can be written as fractions or as whole numbers, or they have a decimal that repeats or ends. However, other numbers that we would square root, for example, the square root of 21. Well, when you square root 21, I don't know what times itself makes 21. And that makes it an irrational number. It cannot be written as a simple fraction because when you square root 21, you get a decimal value that doesn't end or repeat. Now, when it comes to writing powers, you want to use the information you're given to create an expression that has a little power on it. Here we'll write 3 times 3 because it has a length and width of 3. And that's 9, sure, but if I'm writing a power, I just want to write it as 3 squared. I don't necessarily need the final answer. I know it's 9 because there's 9 dots there. But I'm representing it as 3 squared since that's what we're doing with the powers. Next, to simplify the powers over here, I have 3's, but there's 4 of them. So I'll have 3 to the 4th. And then I'll have 7 times 7 times 7. That's 3 7's. But I started with 7, and I'm multiplying them 3 times. Which number is small matters greatly. If I were to mix these up, they wouldn't be the same thing anymore. Our next example is worded in a very tricky way. It says that we're supposed to write the number as a power, but if we're supposed to change 8 into a power, what is that equal to? Well, they tell us to use a base of 2. So starting with 2, how do we get this to be a power that's equal to 8? Well, I don't know what power goes here, so we should probably work it through. How many 2's does it take multiplying to get to 8? You might think 4, but that would be a mistake because what's happening here is we're having to take 2 times itself, times itself, times itself to get to 8. Well, 2 times 2 is only 4, but then 4 times 2, if I add another 2 here, that would be 2 times 2, 4 times 2, that would be 8. So since it takes 3 2's multiplied together to get to 8, our answer is 2 to the 3rd to represent 8. For our final example, we have 3 parts. The first is to simplify, the second is to guesstimate, and the third is to identify a comparison of irrational numbers between the two. So if we're just simplifying the square root of 81, we need to know what times itself is 81. Well, that part's not too bad. Since 9 times 9 is 81, 9 is our final result. Second, if we're estimating the value, I don't know what times itself makes 28. Now, I would never say let's just guess blindly. In fact, I'm going to use a very strategic approach to this. For example, the closest number that can square root nicely to 28 is 25. And I know that if I do square root 25, I'm going to get 5. For comparison, on the other side of 28, I'm going to go up and see what's the next square rootable number, well, the next perfect square above 28. And that would be 36. So I'm going to go ahead and put down that 36. And the square root of 36 is 6. So our square root of 28 needs to be somewhere between 5 and 6. Somewhere in between those two values. Now, it's going to be a decimal. And at this point, I have to kind of guess. But if I'm guessing, I would probably say maybe it's closer to 25 than it is to 36. 28 is closer to 25. So I'll guess something closer to 25, maybe 5.2. If I check with the calculator, I find out I'm off by a little bit. The calculator says it's actually 5.2915, and it keeps going. In fact, it keeps going for a very long time, and it's not about to stop. Now, this problem is asking me to estimate. I know I'm off by a little bit. It'd be closer to estimate 5.3, but I'm kind of proud of my guess that I got fairly close, so I'm going to leave it. For part C, it asks which of these two is irrational. Now, notice one of these numbers was easily square rooted. That makes it rational, and it doesn't have a decimal on it. But letter B, this 5.291502, not only does that number have a decimal on it, but it's not a pattern and it doesn't end. The irrational number between these two is the square root of 28. So, to sum up our introduction to powers and square roots, powers are when you are repeatedly multiplying numbers together, and square roots are when you're trying to figure out what times itself makes that value. And if you're confronted with a number that doesn't square root nicely, think what square rootable numbers that you do know on either side of it. I hope this video has been helpful. Take care of yourself, and I'll see you in the next one.